You're on, 5th grade. Actually, I'm the only one on. I'm so nervous. Hello out there in Cyberville. This is Wednesday, September 4th, year of our Lord 2019. We are in pre-algebra, and we're going to go over real quick. Not a lot of homework so far in pre-algebra. Everybody's happy about that. You only had to do 6 through 14 yesterday on page 8, 7 and 8. So we're going to go over those real quick. The first few were so easy. The first question I think asked, what business showed up the most or something like that. It was so easy. Just look at the bar. Which is the longest bar? Lauren. Restaurants. And the least? Spencer. Department stores. Easy peasy. Now, next question. Did I tell you yesterday I'm right now missing my teacher text? So I'm going off my little cheat sheet here. That's why I'm looking over here. I got the answer down there as 10. Why did I put 10? Why is the answer to the next question 10? Jaden?
Because it asks how much more is something than something.
About how many more certain shoe stores than jewelry stores, right? And they asked about. Now, some of you might have looked at that and said, since it's not quite 20, I'm going to say 19. But they did ask about. So if you put 10, that's great. If you put 9, who's arguing? Because you looked at it as 19 compared to 10. Everybody got that? Yeah. So actually, I would accept both answers, 9 or 10, because you saw that the shoe store was a little less than 20. But they did, in the question, they asked, what was the key word? About. So it was okay to estimate 20 compared to 10. Everybody got it? Next question. Why do I have the answer no? Yeah.
Because it doesn't matter if you have like the least amount of department stores, it could be very small, or I mean very big. So
that's true, but according to the information given to me, could I figure out which one has more floor space? Right. That information does not pertain to this graph. So, of course, that question almost seems so simple, like, why are they asking that, right? You can't tell how much floor space. That's not part of the information given here. And then we go to number 11. Number 11 is they want you to make a bar graph, right? They give you information about movie releases. You may have chosen something different. I chose to make a vertical bar graph. You can tell I chose to make a vertical bar graph because I put my labels down here and my scale up the left side. Everybody with me? Now, always on a graph, you got these two axes together, and this is always the origin, 0. The problem with using 0 in this bar graph is the lowest number on the information on our table is 411, isn't it? Yeah. And it goes all the way over 500. It would be absolutely crazy for me to try to construct a bar graph starting at 0, and even if I counted by 50s, then you wouldn't get a real good read on 411. You know what I'm saying? So I chose to start. I put the jagged line there that says, hey, I'm not starting at 0. I'm starting at 410. And I chose to make each line worth 10. And I made sure I went all the way up to 510. Why? What's my largest number in the information given?
510.
What is it?
510.
Is it 510 or 508?
No. Hold on.
511?
Yeah.
So I should have got out one more? What's the highest? What's the most? What number's the highest?
510. Oh, 510.
510, okay.
Yeah.
All right. And down here is my years. So my bar graph. Are the bars going to be touching?
No.
No. In 95, how many movies released? Johnny Mitchell. Oh, you're just looking at your graph. If you got your book open there. Yes, Ethan. 411. So I'm going to make a bar that goes just over the 410. Yours looks something like that. Yours is probably better than mine, especially if you're using graph paper and I don't have the lines there. How many in 96? Elise, how many movies released in 96? You got your book open? You don't have your book open either. Probably just got your bar graph. Yes, Rachel.
471.
471. Mm-hmm. Now, I didn't take the time to write all these in. You should. 420, 430, 440, 450, 460, 470. So this is going to go up just past the 470. Are my bars connected?
No.
No. I'm doing a comparison of each individual year. There's no like flow going here. There's no intervals, which we'll pick up on the next set of questions. We'll have intervals, so then we won't use a bar graph. We'll use the cousin of a bar graph, a histogram. Kind of like a bar graph, but different because it's not separated by one particular amount or year. It's separated by intervals, right? Okay, do I need to keep going? Everybody gets the point of what your bar graph should look like. If you have questions, let me know. But if you've got these two right, then you probably got the rest right. I probably went a little higher than 470 than I should have. Yes?
I counted by 25.
Okay, like I said, you didn't have to do by 10, right? If you went by 25, the reason I chose to go by 10 is because it wasn't going to be extraordinarily too high, right? 10 was, if I went by 5s, I would, it would be way too big. If I went by 25s, no, I felt like I wouldn't get enough distinction to show the 411. Like, does that make sense?
Yeah.
So I chose to go by 10s because I thought that wouldn't get too outrageously high. Because what happens if your graph, listen, what's the whole point to doing a graph? To make it simple. Who remembers the KISS method?
Keep it simple.
Keep it simple, silly, right? Remember I told you when I learned it, they didn't use silly, they used the other word you're not supposed to call people. But keep it simple, silly. The whole reason you're using a graph is to take information and give people a quick look at it and say, look how simple this is to understand this information. So if I made it by 5s, the person I'm showing the information to will be looking at it like, wow, look up, just way too much. So I made it by 10s. I'm not saying you're wrong making it by 25s. It's just I chose 10s because I felt like I wanted a little more precise than 25. Yeah.
I went by 20s.
Okay. Yeah. It's not necessarily wrong. All right. Everybody understands how to do the bar graph. They don't touch. Next question. If you wanted to get specific answer, you wanted the most specific answer, would you look to the table or the graph? Case. Table. Because it goes to what we're just talking about. He used 25, I used 10, she used 20. When you get to 25, it's hard to tell where 411 is, right? Like if I looked at his and it was 411, it was between 400 and 425. Again, I'm not saying you're necessarily wrong, but it would be harder for me to tell if it was 411 or 412 or 409, right? And the closer we get, like I use 10s, if it's just over the 410, oh, that looks like 411. But no matter what we do on a graph, unless we're counting by 1s, we can't be as exact as the table. Next question. Histogram, right? They give us a bunch of information, a lot of numbers. There's a lot of data there, and number, whatever that is, 13, 12, what is that?
12.
Number 12, they give us a big, long list of information concerning meteor showers. And they say over the last 39 meteor showers, there's been this many meteors and that one, this many. Now your job was to do what? To create a table, putting them in intervals. So the first thing you were supposed to do is make a table, not a graph. So your table should have looked something like, what I did was 1 to 10, 11 to 20, 21 to 30. How many intervals do you think I made? I had to make sure I got how many intervals of 10? All the way through.
Wait, I have a question. It's supposed to be 0 to 9.
Oh, why did I start?
I was like, I didn't.
No, I started 1 to 10. The reason I started 1 to 10, good question. The reason I did 1 to 10 instead of 0 to 9, did anybody else do 1 to 10? Okay. In the other histograms you've seen, they go 0 to 9, right? Or even in the other one, 69.9. Why did I start 1 to 10 on my histogram? What do you think my logic was? Rachel?
Could you count by 10s on that?
Nope. Had nothing to do with the other graph. Dina?
Because it ends in a 60. and
Okay.
69.
That kind of fits my model of how things should end by tens, but that's not necessarily true either.
There's no zero?
Okay, because we're counting how many meteors fell during a meteor shower, right? Would you have a meteor shower if there were no meteors?
Sure.
Yes.
What?
No.
No. So I thought, why would I count 0 to 9 if there are no meteors? There is no 0. There's no 0 in this table. Like, hey, there was a meteor shower this day and there was no meteors. What? That was my logic. I'm not saying you're wrong to go 0 to 9. Perfectly legitimate. It said to go 0 to 9. Well,
Yeah.
Mr. Franken didn't follow the rules. There's a minus for me or someone. You always blame someone else, right? Whoever took my teacher's edition, I would have been able to catch that then. It said 0 to 9. All right.
Wow.
Anyway, so now I feel obligated to change it to 0 to 9 so that we're all on the same page. So you go 0 to 9, 10 to 19, 11 to 20. It messes up all my other
11
answers.
to 20? 11 to 21.
Yeah,
Oh my
What?
See how flustered I am now? 20 to 29. Okay, back to the original question. How many of these do I have to make? How many intervals of 10 do I need to make? Micah, I got to go all the way into the 60s because my highest number is
69.
So then you need to go to
62. So I have to have an interval of
Wait, what?
30 to 39,
So then you have to-
whoop, all the way to 60 to 69. I have to cover that interval, right? And then you simply do this. They call it in the book tallies, right? You simply make tally marks. How many were there between 0 and 9?
11.
Everybody else get 11?
That's right.
Oh, wait, yeah, that's
Okay. So you put 11 tallies there. How many were there between 10 and 19?
13.
And so on. Okay? I'm going to abbreviate it just to make sure you all know what you're doing. Now, when you make your histogram, I got to be able to do this so it can be on the screen. When you make your histogram, it's not going to look like a bar graph separated. You're going to make still got two axes. And when you do your histogram, down here, you're going to have your first interval, 0 to 9. Does that look familiar on your graph?
Yes.
Yeah.
And you're going to have a horizontal or a vertical bar going up. Now over here on the left, these are your intervals. What's going to be your labels up the left side? How did you arrange your left side? I mean, we have anywhere from 1 to 62 meteors. Or we have 39 days, right? 39 different days of meteor showers. Noah, what'd you do up the left side? Yeah. What'd you do up the left side, Dina?
You would take the tally marks and you would take the highest one and then you'd go up to the highest one. Right? Like
But what?
1 to 13.
So how did you distribute them? Did you count by fives, tens?
1, 2, 3, 4.
You just want 1, 2, 3, 4.
Yeah.
Did everybody else do by 1?
No.
What'd you go by?
I did it
Went by 2?
5.
Went by 3s. The example in the book was by 3s.
I did 5.
By 5s. And the highest one was
I did 15.
13.
Yes, I did 15. That was a
I would do a smaller scale than 5. Why? Because again, there's such a small difference between 11 and 13 that I would want to be able to show that difference. So since the highest is 13, 3 at the most, I would probably go by 2. Anybody go by 2? And that would make it so I had to go 7 lines up. 2, 4, 6, 8, 10, and so on. Right? Now my first interval, since it goes to 11, 2, 4, 6, 8, 10, it would look like that. Shaded in. The next interval, 10 to 19. How many were there?
13.
13. So that one's going to be a little bit higher. And the The difference is they're connected, right?
Yeah.
Everybody got it? What's this type of graph called?
Histogram.
Histogram. You're going to run into it next year in algebra. You're going to run into it again in algebra 2 or geometry. And it's always like, hey, remember what a histogram is. You're not going to use it as frequently as a bar graph, but we got to make sure you maintain at least a basic knowledge of what's a histogram for. It's to show or it's to compare things in intervals, whereas a bar graph, you compare things with specific values. Yeah.
I accidentally connected my bar graph.
So you connected your bar graph.
Yeah.
Okay. So in the future, make sure if it's a bar graph that they're not connected because you're not showing
Okay.
intervals.
Right.
Does that make sense? That's it. Okay. You can turn those in on your way out. Go ahead to page lesson 1.3. Oh, no, I'm sorry. Stay on page 8. Just as another time looking at it, we're going to go over 15, 16, and 17 together. Just a quick look at 15, 16, and 17. And the reason I wanted to stay on that is because right now, if you've been paying attention to the news, I didn't want to gloss over 15 through 17. You've been watching this monster storm Dorian just kind of sitting there laughing at everybody off the coast of Florida. I mean, have you been watching the news?
Yeah.
Since
No,
like Friday,
I saw
you don't even know what
that.
Dorian, have you even heard of Dorian?
Well, yeah, we talked about it.
Since I think last Friday or Saturday, they got this huge storm. Anybody see it? They put it like superimposed it over the state of Ohio. So this storm about the state of Ohio was about 50 miles off the east coast of Florida, dead over the Bahamas. Unfortunately, anybody read about that and the destruction in the Bahamas? You guys got to start paying a little bit of attention to the news. This has been like the big thing for almost a week. So this storm has totally destroyed the Bahamas. You know, deaths, buildings everywhere, trees gone, just awful, right? Because it's just sitting there. And at one time, the winds were like 220 miles per hour. It was category 5. And usually the storms, they keep moving one way or the other. Well, Dorian decided to just sit there. And as of this morning, it's just still kind of sitting there, literally moving at one point like 2 miles per hour.
It was 1 yesterday.
1 mile per hour. That's how fast it was moving.
Yep.
Now, the winds aren't moving 1 mile per hour, you understand? The winds are still over 100 miles per hour, but the storm itself is just kind of literally inching along, sitting there, almost like laughing at all the people in Florida and Georgia, like, oh, let's see, am I going to, like teasing them, am I going to come west? Everybody believes it's going to just kind of start to move north and fade away, but we don't know. So now, Georgia, North Carolina, you going home?
No, no.
You all right?
Yeah.
Georgia, South Carolina, North Carolina, they're all going on alert. You know, the emergency people are all getting ready for, because you really don't know what it's going to do. One more statement on that. We got this hurricane, and we're in the moment right now, right? All the meteorologists in the world are studying this hurricane, and it's got them confounded. They can't predict really what it's going to do next. So Mr. Franklin's little sermonette, it's going to take about 10 seconds. They have a hurricane that they're looking at right now, and they can't really predict what it's going to do. Yet there's people that are trying to control our lives telling us that they know what the weather's going to do in 10 years. Think about how silly that is. You know, you heard the people talking about, like, oh, the whole America is going to be underwater in 10 years. They've been saying that for a long time, by the way. Yeah. They can't even predict what a hurricane's going to do. They're looking right at it. Yes.
And about I think it's a week. It's going around the coast. It said it's going to take a week to actually get all the way up. So it's going to do the most.
As of now, that's what they think.
Yeah.
So now, that doesn't mean Florida's and Georgia and all those people are out of danger, because the outer bands of the storm are a lot of rain and a lot of wind, right? So they're going to get damaged. It's just that this huge thing's starting to go north, and then hopefully it just goes whoop right out back into the Atlantic.
They hope.
Back to math. Number 15, how many hurricanes were there in the Atlantic Ocean between 1980 and 1989? Look at the histogram. You can easily see it. The whole point to graphs, they make things easy to see and understand. Brett, how many were from 1980 to 1989? Remember, it says about how many? Okay, if you were rounding it to the nearest 10, get a little more precise. Give me a better, 53 or 52? How many would say 52 or 53? Very good. Next question. Can you determine the number of hurricanes there were in the Atlantic in 1965? Can you determine from this histogram how many hurricanes there were in 1965? Dominic?
No.
No. Now, if they would have made a bar graph and they separated every year, 61, 62, then you would get a bar graph that showed you 65. That's a different kind of graph. The histogram, that's the difference, right? You can't tell exactly how many in 65. They just give you an interval of time. Everybody got it? And finally, number 17, can you use the histogram to predict the number of hurricanes in 2000 to 2009? Based on that histogram, can you predict how many hurricanes there are going to be in 2000 to 2009? Now, of course, remember when this book was published, so it's in the middle of that decade. Can you predict that, Jordan? No. Right? We just kind of talked about how with all the study in the world, they can't really predict what the weather's going to do right now compared to 10 years from now. And there's some hurricane seasons that are worse than others. And listen, even if that histogram went like this, ready? I'll go from your left to right. Even if that histogram went like this, you could start to maybe think you could make a prediction about how many there would be in 2000 to 2009. You understand what I'm saying? Like if you looked at that over the decades and it kept going up and up and up, you might think, I'm going to predict that there's going to be even more hurricanes in 2000 to 2009. You could maybe make that inference, but on that histogram, it goes down, then up. So you don't know, right? Okay, now we can move on to algebra. We can move on to put in letters in our equations. Lesson 1.3, variables and expressions. We covered last week that word expression, right? An expression is just a statement. Allow me to express myself. I'm going to tell you something, right? In math, we call an expression like it's a mathematical statement. It's a mathematical sentence. So a variable, what's that word mean? We talked last week about expression and evaluate. What's variable mean? Just what's the word variable mean outside of math? Let's take the root of the word variable. What's it mean if something varies? Think of the word V-A-R-Y. So varies, V-A-R-I-E-S. What's it mean if I tell you it varies? Jade? It differs. It might be different one day. It changes. It changes. It's not always the same. We got to get something out of your head right away. Because this is actually true. There have been students that thought this. Some students, when they're first learning algebra, you're going to think I'm making this up, I'm not. When they find out, like say they do a problem, they solve for x. They think that's what x always is. Nobody thinks that, right?
No.
Like, there's only 20. Listen, wouldn't it be great? There's only 26 letters in the alphabet. Yes, I found out what x is. Now we just got to find out what B is and C is, and then I'll have it all down. That's not how it works. Because the letters are put into the equations, and they're called variables because x might be 2 one time, 1,000 another time, negative 1.6 this time, right? And usually the common letter is x that we use. Okay, we got another real world problem at the top of page 15. They're talking about a hot air balloon traveling. So, hopefully I can erase this for those out there in Cyberville. The hot air balloon, they're telling us, is traveling, and it says, after the hot air balloon traveled, keep me straight here because, again, I don't have the book in front of me. After the hot air balloon travels for 5 miles, it says they started moving at 6 miles per hour. Isn't that what it says? Mm-hmm. After it had already traveled 5 miles. Now we got to reintroduce you to a formula that you learned back in 5th grade, and that is this. Can somebody tell me what D equals RT means? And what is that the formula for? David.
Distance equals.
Yeah, the R ones, you know what it is, but you can't really put a label on it.
Distance equals something times.
Distance equals something times time. What is that something?
Rate.
Rate. So when I say rate, what's the rate that you're allowed to go on the highway?
The speed.
What is speed limit? You guys pay attention?
70.
So if you're like on Route 11, some parts it's 70. The highest it'll go in Ohio is 70. Sometimes it's 65, sometimes 55. So that's your rate. So the distance you travel is how fast you're traveling, your rate, times how long you travel. Does that make sense? Say amen.
Amen.
The distance I travel, I can figure it out by saying, well, how fast am I going and how long am I going? And then I can tell you how far I went. Does that make sense? How far is that person going? When Lorelai's running, pray there's no bushes. Haven't heard that one in 3 years. When Lorelai's running, if there's no, who's in 7th grade? Okay, so you don't quite get that, Joe. But when Lorelai's running, if there's no bushes, we can calculate, we can see how fast she's running, how long it took her, and then I can tell you the distance that she ran. So we're going to use this idea to solve the hot air balloon problem. They're starting with a real simple problem. What distance did they go? First of all, we know they've already traveled 5 miles. So, by the way, the answer, you're looking at the board, you're looking at the book, down in example 1. They're solving the problem, and I'm going to show you up here kind of the same thing they're showing you there. We've already traveled 5 miles. The information said, then the balloon started moving 6 miles per hour. So I've already traveled 5. So if I want to know the distance, am I going to add, subtract, multiply, or divide? I'm going to add to the 5. I've traveled 5 plus 6 miles per hour. So I've already traveled 5. The question in the book asks, at this speed, how far will the balloon travel in 1 hour? An hour from now. Here we are. We've already traveled 5 miles. Now we're going 6 miles per hour. How far will I have traveled in that balloon after the next hour? I would take 6 miles per hour times, everybody knows when you see 2 variables written next to each other, that means to multiply them, right? I'd have to go, I went 5, I'd have to add to that 6 miles per hour, that's my rate, times 1 hour. What's it equal? 11. That's in your book. Then they say, what if, how far would I have gone in 2 hours? I'm still going 6 miles per hour. Now, I'm multiplying it by 2. 17. 6 times 2 plus 5. Remember order of operations? You can't do 5 plus 6 times 2. You got to do 6 times 2 plus 5. Amen? So if you get 22 there, you got to remember order of operations. Multiply first, then add. Everybody got it? Does that make sense? This come back to you. Beep, turn the page. Oh no, sorry. I always get ahead of myself. Down at the bottom of page 15, there's a couple questions. If you were to travel 3 hours more, then what would be your distance? What would you do? Same thing. You had gone 6 miles per hour, 3 more hours. Well, at this point, no. 3 hours more. You've gone 17. This is what you would do for number 1 at the bottom. You've gone 17. You're still traveling 6 miles per hour. What am I going to multiply it by? 3 hours. That's the time. How far would I have gone 6 hours later? Zach? 35 miles. You see that? 6 times 3 is 18. 18 plus 17 is 35. Of course, you always put your labels. And in English, we have periods after our labels. MI is the abbreviation for miles. If it was meters, would you put a period after the M? No. Number 2, if you traveled a half hour more, that would be the total distance. You wouldn't multiply by you would have to multiply 6 times a half, which is, what's 6 times a half? 3. So you'd add 3. Got it, Case? Beep, turn the page. How long we here?
Uh,
We're not.
Are you serious? When does the class over?
10:46.
Wow. Time flies.
I
Yes.
know.
That's
Wednesdays
crazy.
is like gone before it starts.
When's this class over?
46 after.
Oh my goodness.
I wasn't really checking up. I'm running the restroom if you hear
All
an
right.
explosion. Just
2 ways to take that.
Yeah, that's our class over there.
Is it Wednesday?
Yes, it's Wednesday.
No homework.
Yeah!